And we're going to be doing the same thing, answering questions about probabilities, but this time we're using a table. So this has to deal with breaking up types of dogs based on healthcare and whether or not they're a mixed breed or purebred, and whether or not you spent less than $100 on their healthcare or you spent $100 or more on their healthcare. So what we'll start with is this first one asks for the probability that the person spent $100 or more. That's what we're looking at, according to this first one. So we're looking at just the people that spent $100 or more. Well, if we look at that group, the people who spent $100 or more, how many spent $100 or more was a total of 50. They don't ask what kind of dog, they just said people who spent $100 or more, and that was a total of 50. Out of how many people total did they question? Well, the total here is actually the total of all people is in this lower right-hand corner is a total of 90 people that they surveyed. So we could reduce this fraction, but they'll probably also still want it as a decimal, so I'm not going to bother reducing it. So we'll do the 50 divided by the 90, which is 0.556. And that's our probability of selecting a person that spent $100 or more out of the total of all the people that they surveyed. Let's take a look at B. Find the probability of selecting somebody that says purebred, and then it's got a line on top. Remember, the line on top means you're actually looking at people that do not have a purebred. Well, what's considered to not be a purebred? Well, if you're not a purebred, then you're according to this chart, if you're not a purebred, you're a mixed breed. So let's look at that column of mixed breed. So how many are not purebred, meaning that they're mixed breed? Well, that's a total of 36 people have a mixed breed, a non-purebred dog, out of the total of people that they still surveyed is still at 90. So it's still 36 divided by our total is still 90. And that gives us a probability, if we go ahead and divide that, of 0.4 or 0.40, however you want to look at it. And we are done. Let's take a look at C. Find the probability that a person spent less than $100 on their health care or their dog was a purebred. So there's two things here. So the first thing is that they spent less than $100. That's part one. And then, so that was their part one, spent less than 100. Then there's a key word in the middle, the word or. So I'm going to make sure I include that or. The last part was that the dog was a purebred. So purebred. And that's my second thing that we're looking at. So what does the formula say? I know I'm going to run out of space, so let's go ahead and work it out down a little bit below here. So how many people spent less than $100 first? Well, we already did that. We did something like that anyways. Less than $100. How many people spent less than $100 was the total of 40. Out of, what's the total still? The total is still that lower right-hand corner of 90. So out of 90. Remember the or that we were mentioning that was important that we couldn't skip means that we're going to add up our two groups. And we just have to be careful about any overlap. Our second group was the purebred, which was a total of 54 purebreds out of the total, which was 90. Now here's the problem. We did double count something. So we are going to need to subtract something. Remember, when you're adding, you may get something that's double counted. And what you'll notice is because we used highlighters here, you can actually see what got double counted. What got double counted as both red and orange is actually clearly right here, the 18. The people that actually have purebreds and spent less than $100. That is a total of 18 out of the 90 that got counted twice. So you'd add up and subtract up everything straight across the top. The 40 plus the 54 minus the 18. So 40 plus 54 minus the 18 gives us a total of 76 out of the 90, which gives us a probability of 0.844. Now notice, had you forgotten to subtract an overlap, at least on this particular one, you should have still been able to catch it, because then you would have gotten 40 plus 54, which is 94 out of 90. And it's not possible because you'd be getting a probability bigger than 1. And that should be your hint of, oh man, I can't get a probability that's bigger than 1. What happened? The only time that happens is if you double counted something. You were adding, so you must have double counted. So that would have been your aha moment of, I need to go back and see what got counted twice. Okay, let's try the last problem here. We've already done C, now let's try the last one, D. Find the probability that a person spent less than $100 on their dog or was a mixed breed. So we've got probability of spending less than $100. And again, that was our first group here, spending less than 100. First thing that we'll look at. The next word that's key that we can see, small but cannot be ignored, is the word or. So I'm going to input the word or so I don't forget what I'm doing here. Or what? The second group was that we were looking at a mixed breed this time. So mixed breed. So that will be our second group. So one thing at a time. Our formula says if we've got an or, we're going to be adding, but we have to look at our first group first, which is the people that spent less than $100, which is a total of 40 people that spent less than 100. So we'll do our 40 out of our total, which is still 90. Remember, the or is going to be having you add up this. Now we have to look at our second group, the mixed breed. Well, if I look at the mixed breed group, how many total were in the mixed group? Which was a total of 36 out of the 90. The question when you've got the or and you're adding is, did you double count anything? Is there anything you need to subtract? Well, in this one, you are looking for, is there anybody who spent less than 100 and was a mixed breed? Fit into both categories. And you can see that where the orange and the red overlap again, which is they overlapped at the 21. So those 21 got counted twice. So I need to take out one group of the 21 because they were counted twice. And let's see what happens here. Remember, we've got a common denominator, which is great, so that'll stay the same, which means all I need to do is add and subtract across the top then, which means the 40 plus the 36 minus the 21, which will give us a total of 55 over 90, which gives us a probability of 0.611. And that's our final answer.